Hello again. In this video, we'll cover the things you need to know to complete the second assignment, the empirical assignment for Chapter 11. And the main things that we're going to look at are the linear probability model, Logit, and probit regression. And just like last time, I'll do it both ways with point and click and with a do file. But for this assignment, I really think a do file will be a lot easier to use, and I'll explain why as we get there. I have assigned a version of problem 11.1 in the text, the empirical exercises, and the example I'm going to use to illustrate what you need to do is actually version of example 11.2. It used to be that people could smoke at work. When I was a grad student, for instance, you could smoke in your office, no one cared. People smoked in elevators. And then workplace bans started coming into place. And this study looks at how those workplace bans affected the probability of people smoking. And so the first thing I'm going to need to do is to pull in that data set. So to do it the point and click way, File, Import, it's an Excel spreadsheet. I need to go out and get it here. And it's this one called smoking.xls. Your data set will be a different one. And again, the first row here is the variable names. And so let's click that box, and it looks good. Looks like we're set to go. So let's bring it in. So our data's been loaded. And notice over here, you can get a list of your variables. And sometimes there'll be descriptions over here of the dummy variables and things. In this particular case, there isn't, but often there will be. Okay, so now we have imported the data. The very first question on the homework asks you to do a confidence interval. And I'm going to do a confidence interval for the mean for the number of smokers. So your question is going to be about the number of employed. This is going to be about the number of smokers, and I want to put a confidence interval around that. So the first thing I need to do is get some statistics for that, and so I'm just going to summarize SUM smoker, and this will give me some basic statistics on smoker. So we can see that the mean is 0.2423, and I want to put a confidence interval around that. But remember that this standard deviation here is not the correct standard deviation for a mean, because the variance for a mean you have to divide by n. For the standard deviation, you divide by the square root of n, and n's pretty big here. As you can see, 10,000. So a trick you can use is to say Ttest smoker equals, and it doesn't matter what I say here, 0, 1, I'm just going to put 0.5. It'll do this test, but the test is really not what we're interested in. So let's do this. So the t-test is down here, but I'm not interested in that. What I'm interested in here is this 95% confidence interval. So it's taken this standard deviation here, divided it by the square root of n, which was 10,000, so it comes out the same thing. Just move the decimal point, 0.4285, 4285 up here. Usually they're not such nice round numbers, but this was an easy one. And so then the confidence interval for the 95% is here. And so you don't have to calculate it by hand if you know how to do this with the computer. And so that's just a little trick you can use to answer that question. The other thing you can do is just summarize it, actually calculate the standard deviation, and do this by hand with a calculator. But of course, this is a lot easier. Okay, now we want to run a linear probability model and on a set of variables. And so that's just an ordinary regression. And so we'll start off here. Oh, the first thing I need to do is I'm going to need a variable called age squared. You're going to have to make some transformations as well, some new variables. You'll have to create some education variables and a log variable, but you just use the generate command. So generate age squared. One of my variables over there you can see is age. I want to include age squared in the regression, and it's not in the data, so I'll just create it. is age hat 2, age squared. And that should add it to the data set. It did. Great. Okay, and now we're ready to go. So for the linear probability model, it's simply just a linear regression, just a basic linear regression. So we'll pull that in. And what we want to do is regress smoker on a whole bunch of variables here. I could pull them in one at a time, smoke ban, age squared, and so on. But I'm going to take a shortcut here. I actually have the do file loaded for this. And so I'm just going to copy the variables I need, cut and paste, just to save a little time. So let's go back here and I'll just paste those in. So the variables that I loaded, I could have done them one at a time, are smoke ban, age squared. This is a dummy for high school dropout, high school grad, some college graduate, grad school looks like it's the omitted dummy. Then there's some race variables, black, Hispanic, female. I believe there's a white variable up here. Oh no, there isn't. And so, oh, it wouldn't be white, that would be perfectly multiclinear. And so that should do it. That's what we need. And so let's go ahead and run that regression. Oops. Oh, one more thing. That's not what we need. What did I forget? I better choose robust standard errors, because remember that with the linear probability model, you get heteroscedastic errors. So you always need to correct for that. So now we're set to go. All right, here we go. So there's the results. Now what you would want to do in your problem, it asks for someone of a certain age with other characteristics, what is the predicted probability? And so you would take these numbers, like I could say, for someone who is 20 years old, so you'd put it 20 times this, you'd have this plus 20 times age plus 400 times the age squared coefficient. If they were a high school dropout, this would be, dummy would be 1, the other ones would be 0. If they were black, so you just fill in the dummies and multiply them times the coefficients, add them up, and that would give you the predicted probabilities. And you could do that for several ages. When we get to the do file, I'll show you how to do that automatically. So that's one of the advantages. There's a command I could use right now that would do it automatically for me. In fact, let me just pull that out. So if I were to type in this command, again, I'm just saving time. So I'm going to display something, display. This underscore beta underscore constant, that pulls in this minus 0.04723999. So I want to display the constant plus the coefficient on smoking ban. Oh, I said the wrong number for the constant. The constant is this minus 0.0141099. So that would come in first. And then you would have, I've done it for a workplace where there is no smoking ban. And so the dummy here is 0. And then it pulls in this coefficient, the age times 20. So it pulls in this 0.09 and so on. So you can use this underscore B bracket age close bracket to pull in these numbers automatically. Then you just fill in the values that you want for the coefficient for the variables. So this person, there's a 0 here, so there's no smoking ban. It's a 20-year-old. It's a high school dropout. So these are all 0 because it's a high school dropout. Obviously didn't graduate from college. Non-black, non-Hispanic, and it's a male. And so if I run that command, oops, you know what I did wrong? I can't have it on 2 lines. Sorry. Let me redo that. I need to edit this. It treated when I copied it from the do file, it was on 2 different lines. And so it didn't realize that was all one command. So now I've got it on one line like it should be. Sorry about that. And now it should work fine. So we pull that in, and we can see that the probability for a person with these characteristics, no smoking ban, 20-year-old, high school dropout, and so on, this is basically a 20-year-old white high school dropout, has a 45% chance of being a smoker. Then if we wanted, we could say, well, how does it change if you put a smoking ban in place? So I'll just change this to a 1. And so this is how we can calculate the change in the probabilities. And you just hit return, and you can see it drops to 40%. So it looks like the smoking ban has about a 5% effect on the probability for a 20-year-old. And then I could redisplay these commands, and I could change it to a 40-year-old or a 60-year-old or make them a high school grad or do anything I like. And so that's a nice, easy way for you to calculate these probabilities without having to pull out your calculator. If we didn't use this display command, you'd have to actually do this whole calculation. A lot of them would be 0, so it wouldn't be so bad. But you'd have to actually do this, the constant plus, the age coefficient times 20, and this one times 20 squared, and then the high school dropout. And so it just saves you having to do all that with a calculator. Okay, let's move on to the probit regression. And so I've already have my data loaded here. I still have my age squared, so I'm all set to go. So statistics. And now we want to go down here to longitudinal and panel data. I'm sorry. That's not where we want to go. I'm in the last chapter. We want to go here to binary outcomes. That's what this chapter is all about. And we want the one that says, let's do probit first. Binary outcomes, probit regression. And I happen to have done this earlier. And I did a trial run, and so my variables are already loaded. But normally you would want to pull in smoker, and then you'd pull in all the variables one at a time. Or if you created a global variable like we talked to last time, you could do it that way. I'm just going to cut it. Another way to do it at this point would be go back up here to the regress command. If you're using the same variables, you could just copy those. And that would make it simpler than having to type them all in. So let's pull that in. And that's all there is to it. We're all set to go. So let's just run the probit regression. And here it is. Here's our coefficients. And then like last time, we're going to want to predict a probability. And what you would want to do is take a certain set of characteristics, whether there was a smoking ban in place, age, and so on. Calculate the z-value. You remember that with the probit, what it gives you is the z-value when you run the regression. Then you have to plug that z-value in. You have to look up the z-value in the normal table in the back of the book to figure out the probability. Again, I am going to do this. I don't want to have to do all that much work, so I am going to do this a simpler way. And so I already have it loaded here, but this time I want to remember not to let it break lines. And so this is how you calculate a probability after you've done a probit. And so let's pull this command in, but let me do this right away. So here's the command. This function here, this display normal, open parenthesis, close paren. See the red parens here? What this gives me, this is the cumulative, this is a function that gives me the cumulative normal distribution value. So this underscore beta constant plus beta, this is exactly what we did before for the linear probability model, except this time it gives me the z value. So the thing in here is the z value. I plug it into this normal function, and it should give me back the probability from the normal distribution. This is a cumulative normal function. So let's run that and see what happens and how it differs from the previous. Let's see, there's no smoking ban, 20-year-old, high school dropout. Yep, same person, same example person. So let's run that. And we can see the probability here is 46%. Not really that much different from the 45% we got here. And then if we wanted to, say, try it, what's the effect of a smoking ban, which was the real point of this study, just change the dummy to a 1. Now we've put the smoking ban in effect, run it, and it drops to 40%. So, you know, not a lot of difference between these two sets of results. Okay, finally, we need to run the Logit model. And to do that, we will do statistics. Longitudinal panel data. Sorry, I drifted off there a minute. I'm sorry, I was thinking ahead. Binary, sorry. You want to go to binary outcomes, logistic regression, reporting coefficients. And so click that box. Again, I've already brought in the variables. Normally that wouldn't happen, and normally this would be blank too. So you would say smoker, get your list of variables somewhere or put them in by hand. I'm going to steal them from there. Put in the list of variables, and we are all set to go. So let's run it. And here's our coefficients. And now your problem's going to, oh, here's the pseudo R squared, if you're interested in that. Not so great. We're only getting about a 5% of the variation explained. But what you really care about is the significance, and these are all highly significant. And so even though we're not explaining a large fraction of the variation, what we are explaining, we're explaining fairly well. Okay, so now we need to calculate the probabilities from this logistic regression. I am going to use something I already did so that I don't have to type all this while you wait. But you're going to have to at least once type this like I had to. So I'm going to pull in this function and then I'll explain it. Get rid of the line break problem here. Right person, yeah, 0, 20-year-old, high school dropout. All right, that's it. The thing that's different in here is, remember, for the logistic, it's not, for Logit, it's not normally distributed, but it's distributed according to logistic distribution, which is 1 over 1 plus e to the minus x, where x is the predicted value here from these coefficients. And so this should give me the probability from the logistic distribution. I put in the x value here, put a minus sign in front of it. That's what all the parentheses are about. And use the e function here. So great, we're set to go. Hit return. And we get a 47% probability in this case. So a little bit different, 46, 47. What was our original one up here? I think it was 45. So they're all delivering pretty much the same answers. These are really close, 0.472, 0.464, not a lot of difference. Let's go in and see how the probability changes as we put the smoking ban in place. So there's one. And if you want to, just interested in your problem, you can change lots of other things. What if it's a college grad? How does that change things? Just be careful that you keep the dummies consistent. You can't have high school dropout be one, and or you could have like college sum one and college grad. Sorry, college grad one and college sum one would give you perfect multicollinearity. So you just have to be careful with your dummy variables. I didn't say that very well, but just basically be careful with your dummy variables as you put them in. All right, so let's see what happens with the smoking ban. And it's about the same value, 401, 407. So this is 41%. The change in the probability, if I wanted to get the change, it's pretty easy to do this. In the do file, I actually did it automatically. So I have this command at the very end that will display the change in the two values. So it displays 1 over 1 plus this for without the smoking ban, minus 1 over 1 plus e to this with the smoking ban in place. And so you could do it that way too, but probably not too hard to do that with a calculator. Either way. But this would actually calculate the difference in these two probabilities if that's what you wanted to know. I just took this formula, took the display off and subtracted off this formula. And that's all there was to it. Well, I guess that's all we need to talk about. There's also an F-test, I believe, in one of your problems. But we talked about how to do F-test last time. You just use the test command. And so there's nothing really different there. I just need to get these hard returns out of there so it doesn't think there's a new command starting. Oh, I think I might have actually overwritten something, but assuming I did it okay. Yeah, so there's the difference in the probabilities, 0.06447005. You could do similar up here. Just take display normal this minus normal that, or up here even. And the do file will do that. And so that should be everything you need for your assignment. Just for that test command, suppose I wanted to test that the education dummies were jointly significant. I could say test HS drop equals 0. If you don't put equals 0, it knows. So I'll just say test HS drop, HS grad, college sum, and call grad. So we just want to know, are those variables jointly significant? And the answer is, yeah, they're hugely significant. Your problem asks a question like this, but it asks for the F statistic. What the program gives you is the chi-square. I gave you a hint in your problem about where you can read about that in the text, but there's a relationship between F and chi-square that's fairly simple. It involves a number of restrictions. In this particular case, there's 1, 2, 3, 4 restrictions. And so I can use that to get the F statistic fairly simply. And so I'll let you read about that. But as a hint, it would be around 109.12 if I did the math in my head correctly. Okay, let me clear this off now and let's go to the do file. One thing I want to show you is if you right click over here, you can select certain ones of these and then you can send them to the do file editor. And so I could use the shift command. I haven't actually done this before. like this, and then I could send these to the do file editor and then use it. It just brings in all the commands I've run, and I could use that to then create a do file. I'd have to do some editing and some cleaning up in here, but boy, it would really save you a lot of time. I've got all those display statements in here, all my tests. The logits and the probits ought to be in here somewhere. There's the initial regression. For some reason, the logits and probits didn't come in. Maybe I'm missing them here. Oh, there they are. Yeah, probit, the logits there. And so this would probably run the everything we just did. And then you could use that to edit and make your own do file like I did. So I didn't actually do it this way. I just wrote the do file. But here it is. So we've got this initial stuff at the top that's always going to be the same. Just some notes. You'll need to find your path. If you can't remember how to do that, I talked about that last time. If you say File, Import, Excel, and then import the data set, it tells you what the path is at that point. And so that's fairly easy. It's up here, actually. When I imported the data, see this path? That's what you'll need. So if you just import the data once, you can get that path fairly easily. Okay, oops, wrong window. So it just brings in the data, creates a log file called smoking.log, which will hold all the output so you have access to it later, replaces it if it's there. One thing I've forgotten to say, if you have a mistake in your program, as you run the do file, it'll crash over here and tell you a mistake. This log file gets left open. What you can do at that point, and then if you try to run the do file again, it'll say log file still open. Just click right here and say close. I don't have one open right now, but if I had a mistake in my file, it would leave this open and it won't run until you close that log file. So I meant to say that last time, but I forgot. Okay, so here we are. So data's in, got our log file. Use whatever place on your computer you want. That's just the path. I describe the data, summarize the data. For some reason, it's done twice. I don't really need to do it twice, do I? No. So I'm going to get rid of that. And you know, that's optional. That's not really needed for the problem. I better save this new one. And then summarize the smoking variable. So this tells me about the people who are smokers. This tells me about the people who are not smokers. That's just for information. That's not really needed for the problem. I just threw that in there to take a look at it. But this is where that confidence interval is calculated. So some smoker, you have an employment variable that you'll want to use in the t-test. And again, this value doesn't matter. We're just trying to get the confidence interval for the mean that comes out of the summary here. Then I generate my age squared variable, run a regression on the variables in the model, and this comma R tells it to run a robust standard errors. There's a couple of different ways you can do this, but the comma R will do it. When we actually did it over here, we use VCE robust. That accomplishes the same thing. So either way. And then this does a t-test of those variables. It actually does them every time. That was part of problem 11.2. Your problem will have a different test, and it's not in every part of the problem. And then these are where we calculate the probability. So this is just the predicted value from this regression with various characteristics, 20-year-old, with no smoking ban in the workplace, 20-year-old with a smoking ban, and then the probability difference. Then we just do probit. The command for that is not hard. It's probit. For an ordinary regression, it's reg, probe it, list of variables, and then colon to tell it the line ends, and then the test if you need it. And then this displays, remember what comes, the predictive value from this regression is the z, so display normal, the cumulative normal value for that z. And then we change the characteristics, calculate the difference. Then we do a Logit, same variables, same test. Got a different distribution, so I need a different function over here, but this is going to display the probabilities for me with the logistic distribution, 1 over 1 plus e to the minus x, where x is the predicted value up here. And close the log file. That's what doesn't happen when the program crashes. That's why you have to close it manually. Clear everything. That clears all the data and everything out. And then exit. So let me run this. And I've got this posted in the Pages tab of the class page in Canvas. And so you can copy this or download this file if you want to use as a model for your program. You're going to have to change. You've got different numbers of variables and different variable names. So you don't have an HS grad variable. You'll have something else. You actually have fewer variables. And so you'll need to change things. It's a different data set, different variables, but the reg, probe it, Logit, and the outline of how you need to do things is all the same. And then here's the results, and here's those probability differences we're interested, 0.0644 for the Logit. Up here is 0.062. So those are really close, 0.064, 0.062. For calculating the change, it doesn't make a lot of difference. It's going to be 6% either way. And then for the linear probability model, you do get a little bit different answer here, this 0.047, about a 5%, slightly less than 5% change in the probabilities. And so that should be everything you need to know to get this assignment done. So I will see you again when we talk about how to do the next one.